A rule that is similar to the addition rule is called the complement rule. For example, what if one die is rolled and I ask what is the probability that you will not get a 5? Not get a 5. Well, what happens is here's the distribution of all the rolls and the probability. If I want to find the probability of not getting something, I could simply take 1 minus the probability of getting something. Since all probabilities have to add up to equal to 1, my probability of not getting a 5 is simply 1 minus the probability of getting it. So I could take 1 minus 1/6 and get 5/6 as the probability. Joint probabilities. A coin is flipped twice. What is the probability the first flip will result in tails and the second flip will result in tails? Now, if you want to find the probability of one event occurring and another event occurring, you need to put and multiply those probabilities together. So the probability of getting a tail on the first flip and a tail on the second flip, we can find it by taking the probability of getting a tail on the first flip of the coin times the probability of getting a tail on the second flip. And the answer is 0.25. How about if we roll one die twice? What is the probability that a 6 will occur on both rolls? A 6 on the first roll and a 6 on the second roll. Well, the chance a 6 will come out on the first roll is 1/6. A chance that a 6 will be rolled on the second roll is 1/6. We would multiply and get 1 out of 36. How about this scenario? Two cards are dealt from a deck of 52 cards. What is the probability that both cards dealt will be aces? Well, you may realize that this is a slightly different situation. What if I asked you the probability that the second card drawn will be an ace? Well, it would depend on what happened with the first card. These two events are called dependent events. And it means that the probability of the second event depends on the outcome of the first event. So to find the probability of A and B, we have to take the probability of A times the probability of B, assuming that A has already occurred. So we would find the probability of getting two aces. The probability of the first card drawn as an ace is 4 out of 52. Then we would multiply that by the probability of the second card being an ace, assuming the first one was an ace. In this case, there are 3 aces left and only 51 cards left. We would end up with 12 over 2,652, or basically 1 over 221. So in summary, if we want to find the probability of getting A and B, we have to ask, are A and B independent events? If the answer to that question is yes, then we simply multiply the two probabilities together. If the answer to that question is no, then we have to use this rule where we take the probability of A times the probability of B given that A has already occurred.